All right, guys. So let's do this paper. It is the 2022 exam paper 2 that we did over the weekend. And as of now, the pass mark is only 35%. So everybody should be able to gain this 35%. We're going to move in that percentage mark as weeks go by. Objective, as you know, is to learn from your mistakes. So as I go through this paper, you identify the mistakes you would have made, and the idea is to not repeat those mistakes. That's your primary objective. Right? To learn from the mistakes and don't repeat them when you see similar questions on another paper. It also allows you to get a clearer understanding of the topics and the content and what we're doing. Right? Very important that you do these papers. So I'll give you one paper to do in the class on Saturday, and then there's another one for you to do at home. I know that a lot of you would not have done this at home, the second paper, but have to going forward, we have to ensure that you do both papers on the weekend. 2 papers, one in the class and one at home, right? We have to maximize our opportunities for this exam, right? The more questions you're exposed to, the more mistakes you make now, the less mistakes you will make in the exam room. This is a strategy. The more mistakes you make now, the less mistakes you make in the exam room, more marks you will get. Right. So let's go. I think I'm gonna work this one from number 1 today. Right. I've been working from the back from number 10. I'm gonna work from number 1 today. Since everybody's at home, relax and everything, I'm just gonna work this one from number 1. All right, so let's go. So number 1 is to use the calculator to find the exact value of this expression. All right, so we're gonna just put this in the calculator. We put it exactly as it appears there. And this is why you have to get a good calculator, that you can type this in the calculator exactly as it appears there. So it's a fraction 7/8 plus another fraction 1/6. And then it's a division sign divided by, and then another fraction is 2/9. They want the exact value, which is 1.625, to be expressing it as a decimal, 1.625. But since they give it a fraction, you would tend to want to give them back as a fraction. And it would be 13/8, or it could be this one, 1 5/8. All right, those are all exact values. All right, this one is just exact. Most time if you get a non-ending decimal, a decimal that does not terminate, you don't put the decimal. But the only reason why I put this one this time is because it terminates. Right? It's a set decimal number of places. It's called a finite decimal. There's 1.625 as a decimal. So if you get a decimal that does not terminate, then you don't put the decimal. I don't want to be rounding when you got a question said exact. That's the first part. Next part, first is to calculate this. So same thing again, clear the calculator. I put the same thing in the calculator. So it's 8 over, that's 0.4, 0.4, and that's a cube, 0.4 cube, right? 0.4 cube. And same thing I've typed, calculate up here. You press equal, and that's 125. That's equal to 125. You can see that on the screen. 125 is the answer for that. And then here again, when I do this one, but now they want the answers to 2 decimal places. This is like CSEC ensuring that you don't get 0 in the exam, right? They give you these easy questions. And believe it or not, some people still get it wrong. Because one, they don't have good calculators. They can type this in exactly as it appears there. They have to go in the exam with some basic calculators, right? And sometimes, they're just not careful to enter the values correctly. You have to enter the values correctly. So this is square root. That is 26.8. Come from under the square root sign, and you have subtract 22.5. That's 2.5. Erasing that to a power. and the power happens to be a fraction, and the fraction is 3 over 2. See there? That is it. Type it exactly as it appears there, right here. Square root of 26.8 come from under the square sign minus 2.5 raised to the power of 3 over 2. And the one answer correct to 2 decimal places. So initially, we're getting this value, which is 1.2240024 and so on, right? We want to correct it to 2 decimal places. So this is the second decimal place. I'm going to use this 4 to correct that decimal place. So 4 does not increase 2, as you all know. So this is just 1.222 decimal places. This is it. All right, nice and easy. 3 marks. All right, so that is 3 free marks right there. Let's continue down here now. So this question says, children go to a rodeo camp during the Easter holiday. It says Mrs. Rekha, whatever that name is, buys bananas and oranges for the children at the camp. It says bananas cost $3.85 per kilogram, meaning 1 kilogram of banana is for this amount of money. All right. Mrs. Rekba, she buys 25 kilograms of banana and receives a discount of 12%. So they take 12% off the amount that she's spending, a discount of 12%. How much money does she spend? So if they take off 12% means that she's spending 88%, right? See? If they take off 12% is 100, 100% minus 12%, that's 88%. So she's only spending 88% of the total price. So what is she spending? She spends, this is equal to 88% times the banana amount that she spends for the banana. There's $3.80 times 25 kilograms. $3.85. So that's the amount that she's spending. $3.85 per kilogram multiplied by 25 kilograms. So that's the amount of money that she's spending. Right? That's the cost of the banana, but she's only paying 85% of it. So we can do this in one calculation. We have to be efficient in our work. Right? That's it. Some people calculate the 12% first and then subtract it, but that is waste of time. You have to understand. If you take off 12%, you're left with 88%. If she was paying 12% more, then she would have been paying 112%. Right? You have to understand these simple percentage calculations. So it's 88%. If you want, you could put 88 over 100 times 3.85 times 25. So she's spending $84. I don't put 0.7 is money, so I put a 0 on this. That is money. Money is always expressed to 2 decimal places. So it's $84.70. Are you okay with that? Are you all right with that?
Yes, sir.
All right, next. It says she spends this amount of money inclusive of a 15% tax on the oranges. It says calculate the original price of the oranges. All right. Well, of all the oranges that's about. So you see this amount, it includes 15%. It means that this amount that she spent is 115% of the cost price for the oranges. That's what it means. Because this amount includes a 15% tax. So the amount that she spends is 115% of the cost price. Let's set it up this way. She spends the amount she spends is equal to 115% times the cost of the oranges. And you're trying to find the cost. And the amount she spends is this. Simple as that. Because this amount that she spends includes the tax. Includes the tax. And the tax is 15%. So she's spending 115% of the cost. So if you want to find the cost, you just divide the 115 under here. So the cost is going to be the amount that she spends divided by 115%. Therefore, let's work it out. Cost equals the amount that she spends is this 165. Put the dollar sign on it, Mr. Shaw. Put the dollar sign on it. Dollar sign 165.31 divided by 115%. And you work that out and you get the answer. Fraction is 165.31 divided by 115%. You could put 1.15 if you want. Because 115% means 115 divided by 100. So you could put 1.15. But 115%, you can also put that on the calculator. So it means that the amount that she spends would be, the cost would be $143.75. And if you want, you can reverse the calculation and see if it is correct. You can reverse the calculation by doing a little check, right? If you're not sure. So let's do a little check right here. If this answer that we got is correct. So this is the cost. That is the cost. And she's adding 15% to this cost. So 15% are the tax. The tax is 15%, right? So the tax would be 15% times 143.75. Work that out, the tax. Let's work it out. So it's 15% times 143.75. It will be $21.56. That will be the tax. So the total would be the original amount, this plus the tax. It will be the 143.75 plus the tax that she also paid of $21. Let me shift these over. Some more space to work. Shift it over. Plus the tax of $21.56. Right, this is like a check to show you that the answer is correct. Right, and so this works out. It have this amount that you spent. Get you. Let's add them up and see. So it would be 143.75 plus the 21.56. There you go. See, 165. 165.31. So if you ever in doubt that the answer is correct, there you go. Reverse the calculation and prove it that it is correct. I'm not telling you to do what I just did on the paper in red. You don't have to put this on the paper. It's just me showing you that the concept of the approach is correct. As it proves it, is what it is. Right? 3-1. And that is your little check right here. So this was not absolutely necessary for the exam. That's just a little check. A chest check. Body good? Body okay with that?
Yes, sir.
All right, good. Down here now says no. The ratio of the number of bananas to the number of oranges is 2 to 3. Let's set up the ratio now. So bananas to oranges is 2 to 3. This is the broken down comparison of the actual number that she bought. Furthermore, there are 24 more oranges than bananas. 24 more. So this is really the difference between the number of bananas and oranges. So what I'm going to do, I'm going to extend this ratio to show the difference as well, or the amount more. Show the more. And based on this broken down ratio, the more is just 1 right now. The more is just 1. That is the more. Oranges right now is just 1 more than bananas. The broken down comparison. Now the actual more is 24. I want this ratio now to show the actuals. So to get the more to show the actual, I need the 1 to become 24. How does it become 24? By multiplying by 24. So if I multiply this by 24 for it to show the actual amount, which is 24 down here, I also have to multiply these by 24 to what the actuals are in the number of bananas and oranges. And so over here, if I multiply this by 24, I'm going to get, what is that? 2 times 24 is what? 48. And then multiply this by 24, that's another 24. That's what? 24 times 3, Mr. Shaw. You can't do that. 24 times 3, that's 72. So this is 72. So when there is, if you check this difference, now you're going to get the same 24. Look, if you check this difference, check the difference over here. The 72 minus 48, you're getting 24. And so these are now the actual numbers of bananas and oranges. These numbers right here. And that's how you can do that calculation. It says calculate the number of bananas. This is it, 48. Based on that, there are 40 bananas. Number of bananas. If they wanted the number of oranges, it would be that. If they wanted the total, you would add them. They wanted the total number of fruits. So total bananas is 48. 40 bananas. That is the answer right there. They wanted oranges to be 72. They wanted the total, you add them. That's an easy way to do ratio questions, guys. Ratio question can be done in such a way that you're only multiplying by values and dividing by values to get the actual information that you want. I wanted to practice doing ratio that way because it's just that for me, it's the easiest way to do ratio questions. They didn't give me anything on the ratio about the more, so I extended the ratio, extended the given ratio to include the more. Right? How much more oranges there were than bananas. Extend the ratio to show that. And then the answer work out itself. Nice and easy. What good with that? What
Yes,
good?
sir.
Yes, sir. Yes, sir.
Yes, sir.
Beautiful. Let's go to number 2. This one wants us to factorize this now. So let's use the process that we have learned. Yes, this can be factorized easily because the only factors are 5x. 5x squared is 5x and x. So you could actually know that that is 5x and x. Then one factors of 4 now to go here and here. Right? Such that the far product and the near product is this middle term. So you can actually figure it out quickly now. But let's go through the process. Let's go through the process. All right. With experience, you'll be able to figure them out quickly. Split this middle term. All right, and turn the whole quadratics into 4 terms. So trinomial. So we're using the process. So multiply the 2n coefficients. I call it the AC method. Multiply the a times the c. That's 5 times a positive 4. That's 20. Then you want factors of this 20 that add to the middle term of negative 9. You want factors of 20 that add to negative 9. I'm going to search for those 2 factors down here. Now, since you want factors of a positive number, because the 20 is positive, and the 2 signs, 2 factors, the two factors will have the same sign. So there are 2 positive numbers or 2 negative numbers. Since you want the sum of those 2 factors to be negative, a negative 9, you're going to use 2 negative factors. So we're using 2 negative factors of 20. Now, if you can't see off the bat, that is actually 5 and 4. Right? Because 5 and 4 is 9. You can test the factors of 20 until you find them. So, for example, you could go 1 and 20 are the first 2 factors of 20. Always remember 1 and a number. 1 and the number are the first 2 factors of any number. 1 and 20. Make both of them negative like this. But when you add these, you get a negative 21. That's not what you want. You want negative 9. So the next 2 factors of 20 will be 2 and 10. Make both of them negative. But 2 and 10 is 12. So these add to negative 12. You don't want 12, you want 9. The next two factors will be 3 and what? Nothing. You're looking for whole number factors. 3 and nothing. Then it's 4 and 5. Make both of them negative. And then -4 and -5. Add to the -9. -9. So that's it. You have found what you want. It means that we're going to split this minus 9x into minus 4x and minus 5x. That's what it means. All right? Split that minus 9x into minus 4x and minus 5x. You can put the minus 5x in front. I'm going to put the minus 5x in front because it will factorize nicely with this 5x squared. All right? So back over here now. So this comes back unchanged. It's 5x squared. I'm going to put the minus 5x now. Splitting this into minus 5x and minus 4x. Plus back this for the end. I must always check that what you split the middle term into is giving back the middle term, which is correct. Always do that check. Minus 5x and minus 4x is minus 9x before you proceed. Get into the habit of doing that check. All right? And then we're going to do highest common factor in the first two terms. Highest common factor, not just a common factor. You want the highest common factor of these two terms. That's a 5x. 5x out of this leaves me with an x. 5x out of this leaves me with a -1. The same thing to do is put the same thing in the bracket over here, the x minus 1. You want the same thing in the bracket when you factorize these two. So I'm going to put back the x minus 1 in the bracket. Then in between here has to be a plus value or a minus value, not just a value. Plus some value or minus some value. How do you know that value? I can divide this positive 4 by this -1. That will give me a -4. Divide them. Or I can divide this minus 4x by this x. Still gonna get the same thing, and -4 inside. If you're not sure, you can check it. Minus 4x, 4 times x is minus 4x, and minus 4 times minus 1 gives me a +4. The common mistake right here is that a lot of persons will put x plus 1 inside the bracket because of that plus. All right, so I have to be careful. That's why the same thing to do, as I said, is to write about the same thing in the bracket here first. And then what happens now is that this x minus 1 becomes a common factor, and they are connected with this 5x minus 4. And so when you complete the factorization, it becomes 5x minus 4 times the common factor of x minus 1. Put the x minus 1 in front, same thing. X minus 1 times 5x minus 4, it's the same thing. That is your answer. Whichever one you write is your answer. What go to that? What okay?
Yes, sir. Yes, sir.
Yes, sir.
Then they say we're to hence solve this, and we have already factorized it here. So this now would factor into x minus 1 times 5x minus 4 equals 0. So then it's either the x minus 1 equals 0. You can write it if you want. It's either the x minus 1 equals 0 or the 5x minus 4 equals 0. Or the 5x minus 4 equals 0. The concept is this. If when you multiply two numbers, because that's a multiply, this times this, that's what it is, If when you multiply two numbers, the result is 0. One of them must be 0. Either this is the 0 or this is 0. One of them must be 0. If you multiply two numbers and the result is 0, one of those two numbers must be 0. So put this one equal to 0 first. That's what we have here. And we'll put this one equal to 0. That's what we have here. And those are two possible values that you can get for x that will make the product equal 0. So then you solve this part of it by transposing the 1 over here. It becomes a positive 1, so you get x equals 1. Or you transpose the 4 and then divide by the 5 here. You're going to get the x equals a +4 divided by 5. Those are the two possible answers for x. This and this. Those are your answers. Are you good with that?
Yes, sir.
This one now says we have to make V the formula, V the subject of this formula. So if you notice, you have a V on here and a V on here. So what you want to do, you want to expand it out into separate terms. You're going to group everything with V on one side and factorize it. All right? Expand it out into separate terms. You don't want them to be sort of dividing each other. So the key first step is to take this denominator. You can treat this as over 1. Or you can just take this denominator and multiply it across here. The first step. All right? Multiply that denominator across here. All right? So we would get this times this first. Let me not leave out any step. So I would get W times V minus 3, and you're left with 5 plus V over this side. I want the V terms to be isolated. I'm going to expand this and get W times V minus W times 3 is 3W is equal to 5 plus V. Then these are my V terms. I want them on the same side. And I want this over here. So I'm going to take this V and bring it over here and get WV minus V. That's when this V comes over, it becomes minus V. Equals, this 5 stays on the right side. This minus V goes, minus 3W goes up, becomes a plus 3W. Plus 3W. And I need to factorize the V from these two terms because I want to have one V expression in here. So I get V into, out of this I get a W. Out of this I'm getting a negative 1. What happened here? Okay. And out of this I'm getting a negative 1. And that's all equal to the 5 plus 3W still. Then I take this V W minus 1 and divide it on this side to leave the V as a subject. So the V becomes equal to 5 plus 3W over W minus 1. That is, yeah. So, are you good with that?
Yes, sir.
Are you okay with that?
Yes, sir.
Let me show you something. If you had transpose and put this over this side instead of be the subject over this side, this expression would have become, instead, it would have become the negative. You would have gotten minus 5 minus 3W over, it become negative and it become positive, minus W plus 1. So you could have got this as well. But I think this is a cleaner expression for it. So you could have got this as well. So that's a or. Right? I can multiply the numerator by minus 1, multiply the denominator by minus 1 as well. All right, so that's what you would have gotten if you had grouped the V terms over on this side instead. That's the answer. All right, next question. This question is a variations question. It says the height of an object is directly proportional. The height h of an object is directly proportional. Remember, direct proportion means k times the square root of the perimeter, p, square root. It says write an equation showing the relationship between h and p. It's a direct variation. So the first variable h, because it's a direct, is equal to k times. The second variable is the square root of p. Square root of p. Square root of p. Square root of p. That's the relationship. H is equal to k times the square root of p. That's the equation. 1 mark for writing that. But okay with that? But good with that?
Yes, sir.
All right. All right. Says now, given that h equals 5.4 and p equals 1.44, this is for you to find k. But you can do the question without actually finding the k, guys. You can do the question without actually finding the K, because this question is not asking you for the K. But if you were finding the K, you'd use those two values. Plug these two values in here and work out the K. But you can actually do it without finding the K. So let me show you how to do it without finding the K, because we have to be efficient in this work. They want us to find what H is when the P equals 2.89. Now what you're going to do, you're going to make K the subject of this expression, because the K is a constant. So if you make K the subject, you would take this root P and divide it under here. And you will get that H over the square root of P is always equal to a constant. So for any pair of value, the H over the square root of P is the same all the time. All right? So H over the square root of P for these two equal the H over the square root of P for these two, where you're trying to find this H in this instance. All right? So let's set it up. We know that the K is always H over the square root of P. That's what we know. For any pair of value, that is true, because the K is a constant. I'm going to apply this now. So this H over the square root of this P, let's set it now. This H over the square root of this P, so we're setting it up now. H over the square root of 2.89. Why did I put that first? Because I'm trying to find H. When we set out the equation, sometimes we always put what you want to find first, so it's easier to transpose. So this will be a K. H over the square root of that P is equal to the pair on this one now, which is this H 5.4 over the square root of this P square root of 1.44. That is it. Using this information, put this part in red for you. Let's change that to red. That's what we know from up here. From up here. H over square root of P is a constant for any pair of value. They give us this pair, I'm putting it here. And I want to use this pair now to calculate the H. What is the H when the P is this? So I put that here. And then to find this H, now this denominator multiply it up here. So I say I did not have to work with the actual value for K. If I work this out, I'm going to get K. You know? I work that out, I'm going to get the value of K, but I don't need it. So I'm in a class. A class. So take this now, multiply it up here. The H becomes equal to 5.4 times the square root of 2.89 divided by square root of 1.44. The H equal whatever this works out to, and you did not have to work with the precise or the exact value of K. Absolutely. This question did not ask for it, you don't have to actually work it out. So if you did it away where you worked it out, no problem. Right? But I have to teach you to do the questions efficiently. And that over the square root of 1.44. I've done now, I've typed this thing in the calculator right here. All right, this thing, I'll put it in the calculator. This thing, calculator there. And answer for that H is 7.6, 7.65. 7.65. So the H is 7.65 at that time. And that is it. But good at that?
Yes, sir. Yes, sir.
It's an easy. All right, let's go. Next question. Number 3 is a transformation. First part is a transformation. All right. So it says, the diagram below shows 4 shapes, P, Q, R, and S on a square grid. P, Q, R, and S. So that's a P, looks like the original object. That's Q, that's R, that's S. S clearly is an enlargement took place to the side. And this one is bigger than the rest. All right. It says, describe fully transformation which maps P onto these shapes. So I want to know what transformation map onto those 3. Right? So doing P to Q first, this one to this one. Now, let's look at it. Clearly, there is some turning taking place. right? It's not a translation, because a translation, the object and image look the same. Is it a reflection? I say it's not a reflection because in a reflection, the orientation is reversed. So for example, if you check a point, so you check this point is A and this point is B. That's the inside here, so it's C. Then the orientation for this will be clockwise. If you put this point back as your A, corresponding to here, A prime. Put this point back as your B, right here, B prime. Put this inside little corner here as your C, C prime. Then the clockwise orientation is the same, A to B to C. So the clockwise, the orientation is not reverse. So you know it's not a reflection in a line. Because reflection in a line reverses orientation. So it's not a translation. It's not an enlargement. If it was an enlargement, the size would be different. And we are saying now that it is not a reflection because the orientation did not change. So therefore, it has to be a rotation. It's a rotation. So it is. But to give the rotation, you have to describe it fully. You're gonna have to give the center and the angle of the rotation, right? To describe it as a rotation, you have to give the center and the direction and the angle. All right. So let's read it out. Angle, direction, and center. Let's deal with the angle first. You can find the angle by comparing one side. So for example, here to here is pointing this way. On the image, it is now pointing this way. So on the object, this line that was pointing this way is now pointing that way. That's a complete rotation of 180 degrees. Pointing to the left and then pointing to the right is a 180-degree turn. So we know the angle of rotation is 180 degrees. 180 degrees is the rotation. And because the 180 degrees, it can be clockwise or anti-clockwise. Because if I took this thing and I rotated it the other way instead, the result is the same. So I could have taken this thing and rotated it this way instead. All right, the arrowhead rotated that way instead to be the same. All right, 180 degrees. All right, so we have the angle of rotation. So we're gonna give it direction. I'm gonna give it the direction as clockwise. Let's just give it clockwise. It don't really matter whether clockwise or anti-clockwise no, but let's just give it clockwise. The next thing we need to find is the center of the rotation. But the center of the rotation is always an invariant point. And also because this is a 180 degrees rotation, a 180 degree rotation is the same as a reflection through the center point. So if we join these 2 points here and here, right? Join those 2 points here and here, like that. Then the center of rotation would be here. Because it means that this line that I've drawn, I could say this arrowhead, would have been rotated about this point, 180 degrees, and is now pointing this way. That's telling me that that is the center of the rotation right now. Simple as that. That point is the center of the rotation. Right? I just joining those two corresponding points because I know a 180-degree rotation is the same as reflecting to a point. Right? So because we have a 180-degree rotation, we can view it as a reflection of this point through that center point there to give it that. So therefore, this is the center of the rotation. More things you know, the better, guys. More things you know, the better. 180-degree rotation is the same as reflecting to a point, to the center point right here. So the center point, what's coordinate of that blue point? It is 7, 7, 7, 7. So the center point is 7, 7. And all we need to do now is give that description. So 180 degrees clockwise rotation about the point 7, 7. Let's go. So the first one here is 180 degrees clockwise. You can put anti-clockwise if you want. Rotation about the point 7, 7. That is it. So for this one, you are given the name, rotation, and the three components of rotation are the angle, the direction, and the center. Rotation must have those three components. You give the name and the components when you're describing the transformation. Angle, direction, and center. Right? So that is it. And this is a little bit. So give the angle, the direction, and the center in the description. All right, better go do that one so far.
Yes, sir.
Okay. All right, so let's take these off now. So sometimes use the process of elimination, right, guys? It's a process of elimination. So this becomes the center of the rotation. This point is the center of the rotation. It's a 180-degree rotation, 180 degrees rotation about that point. All right. So let us see now. Let us see now. The next one is to R, right? So it's to R next. To R. So how did we go from P to R? Now this one, now the orientation is reversed. You can look at it. Let me take this off. We worked it out. Let me take this off. Let me just leave the center point alone, which is right here. All right. So I'm comparing these two now. That one, the orientation is clearly reversed. Let's look at it. So I know it's a reflection in a line. It's not a translation, because of our translation, the image and the object look exactly the same. It's not an enlargement, right? Is it a rotation? It could be a rotation, or it could be a reflection. So to make the distinction between a rotation and a reflection, you check the orientation. If the orientation is reversed, then you have a reflection. Again, we can use these 3 points. Treat this as A, treat this as B, treat this as C. Three corresponding points will be A prime, B prime, C prime. This one has a clockwise orientation, A to B to C. A to B to C, and this one is anti-clockwise. Orientation is reversed from clockwise to anti-clockwise, so you know we have reflection in a line. Reflection in a line reverses orientation. So you know that this transformation is a reflection in a mirror line. And the mirror line is going to be halfway between the corresponding points. Right? So the mirror line is going to be halfway between these 2 points, halfway between them. It will be right here. And halfway between these 2 other corresponding points up here. You can choose 2 other ones. Let's say choosing these 2. Or these 2 instead. These 2. Closer. So again, you see that it is halfway mark is right here. All right. So you know the mirror line is this blue line right here. That's the mirror line. That blue line is a vertical line passing through 1. So that mirror line is a line x equals 1. Vertical line passing through 1 is x equals 1. It is x equals 1. Blue mirror line that reflects this onto that. When you're describing a reflection, you just need to state the mirror line. State a reflection and state the mirror line. That line is x equals 1. Vertical line passing through 1. So let's do that now. So this is a reflection in the line x equals 1. That's it. So for this one, you give the name, which is a reflection. And a reflection has one component, the mirror line. State the mirror line when you're describing a reflection. Reflection has one component. But good so far. But okay?
Yes, sir.
Next one is to S. And the block shape to S. Alright? Take off this down here. Let's write. Let's leave it here. Blue line here. X equals 1. Right? So we're going now from this shape to this. Now, clearly that is an enlargement. Enlargement has two components. Enlargement has a scale factor and it also has a center. Now we can look at it and know the scale factor. From this to this side was 1 unit and it has grown to 2 units. It has increased to 2 units. So you know that the K is equal to 2. It's an enlargement. And it's K equals 2 right now. Because we could choose one side and say, oh, by what multiple it has grown. They want to find the center of the enlargement. Find the center of the enlargement, you join the corresponding points and extend it out. Join the corresponding points and extend it out. So for example, you can join this point, zoom it up. You can join this point and this point and extend it. The center is going to be somewhere up here because the enlargement is in this direction. So like you have a focal point. It's like you have a light out here shining this way and making this cast a shadow. The enlargement is like a shadow. Right? So the center is somewhere up here. But to find the center of the enlargement, you can join the corresponding points and extend them back. Right? So I can join this point and extend it back. Something like this. And then extend that line back. Try to get it straight. Up to just straight line. 2 points. Looks like up here. Looks like it is up here, guys. Right? And then you can also join these 2 points. This and this are corresponding points as well. You could have used these 2 points as well. This one and this one corresponding. You could have extended back that way. I could have used this one and this one, these two. This one, these two as well. I got a tick here and this. Use a ruler and draw a straight line back like that. Alright? I'm going to use these two easy ones. So I'm going to use this one and this one. Clearly now will be on this vertical line. Those two. So extend this back. Right? See that those construction lines that I've drawn, they meet here. That looks like the center of my enlargement. Right there. Alright? So what did I do? Let me go again. Put the center point at different color. Blue. So I join these two corresponding points, extend it back. Join these two corresponding points, extend it back. Right? And they meet to the center. Now you can check if it is right as well, because the scale factor also affects distance. So, for example, this distance to this point is 3 units. And that distance was doubled to 6 units down to this point from 6. That has grown by 2. This length was doubled to this length as well. So scale factor does not only affect size, it also affects distance. So the center of the enlargement is this point up here. That point is 7, 11. 7, 11. 7, 11 is that point. So the center is 7, 11. So it says an enlargement, and I give those two components of enlargement, scale factor and the center. All right, so let's just do that down here. So down here, we have an enlargement of a scale factor A equals 2, I can just write 2 with center center is 711. 711. We'll say about the center 711. So for an enlargement, you describe an enlargement, you give the name enlargement. Enlargement has two components, a scale factor and the center. State those in your description of an enlargement. You cannot describe an enlargement and not state the scale factor, the center. That is it. Everybody good with that? But okay?
Yes, sir.
Alright, good. Then the next part now says on the grid, page 10, we are to draw the image of P, same original triangle, after translation by a vector negative 2, 3. I must label it P. What does negative 2, 3 mean? Negative 2, 3 translation means 2 units to the left. So let's have a point here, it's going to move 2 units to the left. That's a minus 2, starting from here. So if you have a point A here, and they're going to go 3 units up. 3 units up. 3 units up. That's where the image point would be, A prime. You apply this translation. Right? So it's 2 units to the left and 3 up. So when I move that shape, 2 units to the left and 3 up. And because it's the same exact shape, we can move 1 point and draw by the same shape around that 1 point. Right? So it's 2 to the left, 3 up we're doing. 2 to the left, 3 up. Doing it on this. So let me take these off now. Take these off so we can see it. That picture, have to take them off the diagram. Take these off so you can see what we're doing. Well, the recording is there, so you can all go and watch the video to see how everything looks. We got everything again. Alright. So we're gonna move 2 to the left, 3 up. So let's say we're using this point. 2 to the left, 3 up, and then draw about the same shape around that 1 point. Let's go. So check the scale here. So every grid is 1 unit horizontally. Every grid is 1 unit vertically. Alright. Check 5 to 6 horizontally. And vertically, sorry, and 2 to 3 horizontally. So every grid is a unit. You have to always make that check. You want to go 2 to the left. This point is coming to here first. That's 2 to the left. Then 3 up. 1, 2, 3 up to here. So this point is going to come to here. And you just draw by the same shape around this point. Like this. So this horizontal piece was 1, 2, 3, 4 units. You're going to draw back a 4 units piece for that now. 1, 2, 3, 4 units. Draw that over 1, 2, 3, 4 units. This piece up here is 2 units tall. So this coming up 2 units. And on top here is 1 unit on top. This is 1 unit down here. And this up here says 2 units across here. And then it's like a diagonal piece come piece of shape. And that's it. And so I must label it T. So that is the image right there. They move 1 point and then draw the same shape around that 1 point. And that completes your translation. Go to the left, 3 up. And then I must label it to a T, right? T. So I'm going to put a T on it. So let's put a T right here on it. T. That is it. But okay with that? Everybody good?
Yes, sir.
We're putting back these lines. This to this. 14 back to this. That's a construction limits for the enlargement to find the center of the enlargement. All right, that is that. Use the purple for the rotation on this. Put by the rotation line. So this point was rotated to this point 180 degrees. So it's just a straight line through it like that. This becomes the center of rotation. Right? For the first part, where a rotation of 180 degrees, so here, 180 degrees rotation about this point for the first part. All right, is that. After I finishes that question, guys, that finishes that question. Question 4 now. Question 4 says functions f and g are defined by this. So this is the f function, that's a g function. It's a functions question. They want g of a third. G of a third means they're going to put a third in g function right there. But we made a mistake of putting it in the first one, which is wrong. This is f. Be careful, put it in the g. That's a g. So it becomes equal to 3 times a third minus 1. Minus 1. All right. And that becomes 3 times a third is 1 minus 1. 1 minus 1 is 0. The answer there is 0. Next part, f to the minus 1 of negative 3. Let's just write down what f is. F is equal to 5x plus 7. 5x plus 7. And there are multiple ways to do this. Multiple ways to do that. What I'm going to use is the method of finding f to the minus 1 of x first. For this, I'm going to find f to the minus 1 of x first. Then I will do the x to the minus 1 of the negative 3. That's the method we're going to use. So let me shift this over. So start with the f right there. I want to inverse it first. So inverse this f. The f becomes x. 5 times this x becomes f to the minus 1, which is the inverse function, plus 7. You want to make this f to the minus 1 a subject. If you want this 7 first, it becomes x minus 7, and then take this 5 and divide under here. Over 5. That becomes your f to the minus 1. That's f to the minus 1 of x. Put in by the of x now. And you want f to the minus 1 of negative 3 now. So you come down here now and say, therefore, f to the minus 1 of negative 3. We're going to put negative 3 in this now. So it's going to become equal to negative 3. That's this negative 3 minus back this 7 minus back this 7 divided by 5. That becomes negative 10 over 5. Negative 10 over 5. That is the answer, negative 2. This is the answer right here. But good at that. So here when we inverse the function, inverse it. We can change the domain and the range, just like that. But okay? But good? All right. All right, next question. Next question is this coordinate geometry. It says the line L is shown on the grid below. All right, so this is the line L. As you look at this line L, we can see that the C value is 1 and the gradient is rise over run. So we can maybe use these 2 points for the gradient, for example. This and this. And from that to that, it's a rise of 1 and a run of 3. So run equals 3. Run equals 3. Rise equals 1. So you know the gradient. So you can get the equation easily. Means that the gradient is 1 over 3. And the C on this line is 1. So usually when you get it on a graph, you don't need no calculation. See there? Write the equation in this form, y equals mx plus c. You can write it down. C is 1. I have this on the diagram. I'm leaving it on the diagram. But C is equal to 1. And the gradient m is rise over run. And I have the rise and the run on my diagram, which becomes rise 1 over run 3. So the equation then is y equals mx plus c. So it's y equals a third x plus 1. That's the answer right there. Simple as that. But good? But okay?
Yes, sir.
Next part now says, equation of a different line is this. It says, write down the coordinates of the point where the graph crosses the x-axis. Now, on the x-axis, y equals 0. That's what you know. But you're going to put the 0 in here to see what the x is. So y equals 0, you're going to have 0 equals minus 2x plus 8. Transpose the 2x, you're going to get 2x positive 2x equals 8. Divided by the 2, you get x equals 4. So that point Q, or not Q, the line is Q. So that point is 4, 0 on the x-axis. That's the answer. X value is 4, y value is 0. The line is Q, not the point. But okay with that? That is the point. 4, 0 on the x-axis. Next part wants a point where it crosses the y-axis. On the y-axis, x equals 0. So if x equals 0, this one is easy. X equals 0, and put the 0 in here. You gotta go y equals the c value is 8. That one's kind of straightforward. Y is equal to 8. Alright? X equals 0. Right? I can put it this way. The y becomes, when x is 0 on the y-axis, the y becomes, this y becomes minus 2 times 0, but x value is 0 right here, plus 8. So the y value is 8. And so the point is 0, 8, 0, 8, that point. That's the answer. Those are 2 points on the that line. 0, 8 on the y-axis, 4, 0 on the x-axis. All right, question asks for coordinates. So you have to write coordinates like this. Both values, same thing here. So for coordinates, you have to write coordinates like this with both values, the x and the y values. So one of them is 0. All right, so I have to remember that. All right, then they want us to on the graph draw the line Q. So it's gonna draw a line between these 2 points, 4, 0 and 0, 8. 4, 0 and 0, 8. So 4, 0 is right here. Let me draw it in purple. I'll leave it in blue. 4, 0 is right here, guys. 0, 8 is right here. In the line connecting those 2 points now. So let's do like this. That is it. This is the line y equals minus 2x plus 8 plus minus 2x plus 8. So let's write it better. Y equals minus 2x plus 8 is equation. All right. And clearly know that's a point of intersection of the 2 lines. Now we're going to ask about this point. This point is the intersection of the 2 lines right here. That point is 3, 2. Intersection point is 3, 2. Must ask for the intersection of those 2 lines. Right? That's what I need. That's all these questions are. Right? So we've drawn the line up here. Now it says, according to the graph, solution of system for line 1 and line 2 is a point where they intersect, point of intersection. So I have to write it down. It is 3, 2. I have it on the graph. I just need to write it down. It is 3, 2 intersection. Intersection 3, 2. So this is. That's a solution. It's point of intersection of the two lines. 3, 2 right here. Right? That question done. Very good? But okay? All right. Let's continue. Number 5, statistics. Number 5 says, school nurse record the height each for each of 150 students. This is important. 150 students, right? And lose sight of that. In class A, who was vaccinated? The table below shows information, right? So they are giving you class boundaries. I see where this one ends, this one starts. So these are class boundaries, and these are the number in each class. So remember, this is on group. This is group data. So everything you do here is estimate, because for example, in the first group, you have 4 persons measuring between 60 and 80 centimeters, but you don't know the actual height of those persons. All you know is that 4 of them measure less than or equal to 80. That's all you know. You don't know what the actual height is for them. Everything you do here is going to be estimation. It says, complete the table below and use information to calculate an estimate. See? An estimate of the mean height of the student. Give your answer correct to 1 decimal place. So I want the estimate of the mean. Let's write the formula for the mean. Remember, the formula for the mean and the estimate of the mean is the sum of the sum of fx divided by the sum of f. That's an estimate of the mean is equal to that. This is the f column, fx column, sorry. Call this a sum column. It's a way of summing the height of all 150 students. I like to call it the sum column. What we are doing here, guys, we're using the midpoint values to represent the group. So the assumption is like we're saying all 4 students in this group, all of them have a height of 70 centimeters, which is the midpoint value for the group, which is not true. And that's why we're only making an estimate. Same thing here. We're assuming that all the 20 students in this group, because we don't know what the actual heights are of those students, we're assuming all of them measure 90 centimeters, which is the midpoint of the group. Again, that is not true. It's not true that all of them measure 90. But for the purpose of estimating the mean, that's what we do. Now, if all 4 students in this group measure 70, then the total height of these 4 students is obtained by multiplying these. That's how we get the 280. And then same thing in the second group. 20 students measure 90, you multiply them, the total height is 1800 and so on. So that a quick way of roughly estimating what the height of all the students is throughout, doing it group by group. So the midpoint, no, you can, the midpoint value for here is going to be 130. Oh, no, because the lower boundary going up by 20, upper boundary going up by 20. The midpoint will also therefore go up by 20. See, going up by 20. So this don't need no calculation. Just add 20. All right, the values are increasing by 20. Class which is 20. So they're just gonna add a 20 to this, and you're gonna get 130 by adding a 20 plus 20. All right, everything going up by 20. And then now, when we do this calculation, this times this to get the value here. All right, so let's do that in the calculator. So it becomes 67 times 130. That becomes 8710. Then we need the sum of the sum. We know that sum of the frequency here is 150 already, sum of the students. The number of students is the sum of the frequency, which is equal to 150. This is supposed to be 150, because there are 150 students. And we need to sum all the students now. This is the sum of students, 4 students in this group. This is the sum of students' height for the ones in this group. This is the sum of the height of the students in this group. When you add up all of these, you're getting the sum of height of all 150 students. So we need the sum of fx here now. So we're going to add up all these values now. So it's going to be 280 plus 1800 plus 3850 plus 8710 plus 3000 plus 680. So we're getting 18320. It's the sum of the height of all 120 students, approximately. But we use a class midpoint to represent each class. Just looking back at the values, make sure 280, 1800, 3850, 8710, 3680. Good. So this then becomes equal to the sum of height of all of 150 students, 18320, divided by the number of students, which is 150. That gives you the mean height of a student, 18320 over 150. That's 122, and I'm going to give it to one decimal place, right? One decimal place. 122.1, you have to give the height in centimeters. So the mean height is also going to be in centimeters. Very important that you put on unit of measure there, centimeter. All right, look, everybody good with that? But okay?
Yes, sir.
All right. Next part down here now, talking about standard deviation, right? CSEC will not ask you to calculate standard deviation, they'll ask you to compare standard deviation. Let me say it one more time. Standard deviation is a measure of how the data is spread away from the central, from the mean. How wide is the height of the students from the mean height? How wide is it? Are the heights of the students very wide? Are there some very short students and some very tall students? Are the heights of the students more closely spread from the mean height? Are the height of the students relatively close to one another? That's what standard deviation measures. The higher the standard deviation is, the wider the spread of the height of the students from the mean. And they have to put in from the mean. Standard deviation is measuring spread from the mean. So the higher the standard deviation is, the more the spread is of the height of the students from the mean height. And what they're going to do, they're going to ask us to compare the spread of two groups. That's the syllabus, that's the limit of the syllabus where standard deviation is concerned. That's why it's only a 1-mark question, an explanation question. Let's look at it now. So in class B, the mean height is 123.5. It don't matter what the actual mean is. Standard deviation is the measure of the spread from the mean, regardless of what the actual mean is. The comparison is how the heights of the student is spread from the mean. All right. So this actual mean is kind of irrelevant. But the standard deviation is 29.87. This is important, this figure. It says for class A, the standard deviation is only 21.38. This is a higher value. This is a lower value. The standard deviation is higher. This one is lower. So the higher the standard deviation is, the higher the spread, is the more spread you have. The spread is more wide from the mean. Right? So that's all they're looking for. Which one bigger, which one smaller? The bigger standard deviation is, the wider the spread. The smaller, the lower the standard deviation is, the closer the spread from the mean. Means that when the standard deviation is low, it means that the height of the students, they're relatively close to one another. Relatively close to one another. In this class, where the standard deviation is higher, you might have some very short people and some very tall people. In this class, when the standard deviation is less, it means that the height of the students are not so wide. The height of the students tend to be closer to each other. That's what it means. The spread is not very wide, and not as wide as this one. Question says, use this information, provide a response to comment on the distribution of the height of the students in class A and class B. Now, this is class B, right? And this is class A. So the class B students have a wider spread from their mean height compared to class B. Or if you're using class A as a reference, the students in class A, the height of the students in class A have a more closely spread because they are lower value, closely spread. So this is a more wider spread. Let's write it down here. So this will have a wider spread. And this is a closer spread. I'm going to write something to that effect now, right? So a typical example is that either they're going to use the B as their reference for the explanation or the A as a reference for the explanation. If I'm using B for the reference, I'm going to say it has the height is more widely spread because it has a higher value than A. If I was using A as my reference, then I would say it is more closely spread than B. All right, I'm just explaining this a little bit more than I would because I want you to be able to explain it if I get it. But you would write something looking like this now. You write something looking like this. I'm going to underline key phrase that you must put in there, that it is a spread from the mean. From the mean. All right, let's look at it. Let's look at it using B as a reference, right? Let's use B as a reference. So the class, the height of the students in class B, the height of the students, HI, the height of the class B students are, see, more widely spread. They are more widely spread, are more widely spread from their mean height compared to the class A students. So this is what you must say in it. You have to say from the mean height. You have to say from their mean height. It's a comparison of the spread from the mean. So you have to put this in there from the mean height. It's a spread from the mean. That's it. If you're writing it from the reference of the A, or I could write it from the reference from the E class, using the E class as my reference. I could say something like this instead. I could say the height or the heights of the class A students are more, class A students, standard deviation is less. So it's a closer spread. So you say it's more closely spread, it's more closely. See, keyword. Because of a higher value, use widely spread. Now we're going to use closely spread because it's a lower standard deviation. So use a word like closely. It's more closely spread. And the spread is from their mean height compared to the class B students, now comparing with the class B. compared to the class B students. So you could write either this one or this one, anyone you want to write. Something like that. Again, you're making the description, you have to put in this line from their mean height. From there. All right, but good? But okay?
Yes, sir.
Good. Next part. One question I don't need. A long question. It says, complete the cumulative frequency table below and use the information to construct the cumulative frequency curve on the grid provided on page 19. So we need to complete this cumulative frequency. Is that a frequency? Adding up the frequency. Remember, the cumulative frequency curve is the best way of lining out the students, the best way of simulating, lining out the students in ascending order for the ones who have the lowest height to the ones who have the highest height, because they don't know the actual height of the students. Was the best way of kind of estimating, lining them out in ascending order. So from this one to this one, we're gonna add this 35 here. So it's 24 plus 35 for this value. They're adding 35 more students to the line. That works out to be 59. And 59 plus 67 is 126, which is right. And then here I have to add this 20 to this now to get that one. It's 126. 126 plus 20. That's 146. And then 146 plus 4 give it a 150. All right, so that is that. Now we need to plot these points. I guess we have to plot these points and these points on the graph now, right? So it's a 59 and the 146. I have to put on the graph, I'm sure. They usually give you the values that they usually put in the points that they give you on the table. And then you have to put in the ones that you have to work, that you worked out. I said go on the graph and put them on. Complete it, right? All right, so let's double check some of these now. So 100 is that. That we're doing. So based on the graph, it's using less than or equal to values, right? Using these values. The graph is using these values. Graph is using these values. Or limit values, or boundary values, sorry, with the cumulative frequency. That's what they're using for the graph. I must always bring a graph down to 0. So the value before 80 would have been 60. The value before 80 would have been 60. 60 is a frequency across here of 0. All right, okay, I must always bring a cumulative frequency graph down to the x-axis there by putting the value before this one. Oh no, it's 60, but it's going up by 20. So the value before 80 would have been 60, and that's a frequency of 0. So it will be less than or equal to 60. And that's 0. And it kind of makes sense because the things start at greater than 60. Right? Start at greater than 60. So it means that none of the students was less than or equal, was 60 or less. Everybody was more than 60. That's what it means. All right. All the students had a height greater than 60. There were no student that was 60 or less. That's why we have this point down here on the x-axis, this point down here. 60, 0, right there. Right? If there's not a point on the table, you have to add it. All right. So putting in now the point for 120. So 120 less than 120 was 59. So we need to find 59. And less than 160, 146. So it's looking for 59 and 146. So looking for 59, 146. So this one corresponding to 120, and the 146 corresponded to 160. 160. Right, let's put them on. So 59. So you have to do now is make sure you get the scale of the graph properly, right? So look at it now. Down here from now. There are 5 lines between 0 and 10. So it's 10 divided by 5 equals 2. Each of these little grid is 2. Make sure you get the scale right. So put a note on it from now. Everything important. So each of this is 2. So I'm putting a 2 here to remind me. Then horizontally now, this is 20 years and 10 lines. So it's 20 interval divided by 10 lines. Each line is 2. So it's 60. So right here says 70. Because this is 2. This is 62. 62, 64, 68, 66, 68, 70. So each of the lines on this now is 2. Right? So that's something of 62. You just have to remind me. Each of those lines is 2. All right? Just in case we're going there. But let's put in the points in blue. So we said the 120 corresponded to 59, right? Less than or equal to 120 is 59. Another thing, guys, this graph is a less than or equal to height graph. Less than or equal to height that it is showing. Why? Because we use less than or equal to upper boundary values to get the points. So it's showing how many students were less than or equal to any given height. What it is showing. So 120 was 59. So say 50 or so. This is 58. So 59 is right in between here. So coming right in between here, I'm going over to 120. So 120 or so. So the point is here. That's a point. That point right there. 59. The next point was 160. 160 at a cumulative frequency of 146. There's 169. Let's mark it. This is the 169. But we need now 146. All right. So this is 140. 142, 144, 146. This is the 146 line, 146. So you're on this line, going across on this line until you reach the 120. So we're talking about right here, the next point. All right. And that is basically those are your points. It's going to draw a smooth curve through those points now to get the O-give shape. Smooth curve. All right. So see if we can do it. I'm going to go something like this. So a smooth curve through the points. That's good enough, I think. I'll put this on the exam paper and they will give me the marks. That's the O-give shape, guys. Right? That's a curve. And they wanted us to get something from it. All right. So that says use the graph to find an estimate of the median height. Median height is Q2. Remember, it is Q2. I want Q2 is the median. And Q2 corresponds to the height of the student in the middle of the distribution, or there were 150 students. So the position of Q2 would be half n, which would be half of the 150 students, which would be the 75th student of the portion of Q2. And they're going to read Q2. This is just the position of Q2, not Q2 itself. So we can find the 75th student. So the 150 students here. So the one in the middle, use a different color. Let me use the red. Is Q2. That's the 75th student. The 70 and 80. 75th student is right here. The position of Q2. That's 75. That now is the position of the median Q2. It come across on the graph. Right? And then you read it down here. Looks like it's on this line right here. Right here. And then you read that value. Zoom it up. That's Q2. That's your Q2. second quartile. Right? And that be the scale proper. Remember, every one of these lines is 2, right? So this is 120, 122, 124. Want to make sure 124, 126, 128, 130. This will be 130. Alright, so that is clearly 124. Q2 is 124 centimeters. 124 centimeters. That's Q2, 124 centimeters. Let's write it up here. So this is Q2 is 124 centimeters. That is it. All right. Shift this down a bit. The next part now says we have to calculate the probability that student chosen at random was taller than 130. This means greater than 130 centimeters. To find how many was greater than 130 centimeters, we need to find how many was less than or equal to 130 first. That's what the graph will show you. How many was greater than 130 centimeters. So when I say less than or equal to 130 first, that's what the graph will show you. How many students that is less than or equal to 130 centimeters is how many students? The graph will show you that the rest of them is greater than 130. Let's see how many less than 130 first. So we're going to come on the graph of 130, which is here. This is 130. So it's in purple, this last one. So this is 130. So come on the graph. This is the 130 line here. Come on the graph on the 130 line. It's like about here. Come across and read it. It's here. That's 92 students, right? But every line is 2. Vertical axis is there. Every line is 2. I'm putting about that 2 down here. So be careful with the scale, guys. Every line is 2, right? So this is actually 92 students. 92. So 92 students was less. So the rest of them is more. So 92 students at a height less than 130. Less than equal to 130. So less than equal to 130 was a height of 92 students. Therefore, greater than 130 centimeters. Greater than 130 centimeters is 150 minus 92. Right? Close the door, please. Close the door, please. That's 58, right? So what the probability of getting one of those students. So therefore, the probability of being greater than 130 centimeters is 58 students out of the 150 students. That can give that in voice terms quickly, which becomes as a fraction. That's 29 over 75. Plus 29 over 75. And that's the answer, right? That's it. Done. But okay with that? Students good with that?
Yes, sir.
Yes, sir.
Good. So remember now, this taller than 130 means we're plus greater than 130 centimeters. But the graph is showing you less than or equal to. So you find how many was less than or equal to, the rest of them is greater. Right? The graph is showing you this. The graph is showing you this. Less than or equal to 130. Let's shift this over. All right, that is that. All right, let's continue. What a question done. A question done. 9 marks for that. So let's go on now to number 6. Number 6. Number 6 gives us this solid object with uniform cross section. So no, it's a solid geometry, right? It said the diagram below shows a solid with a semicircular cylindrical base. That's down here. Right? With a rectangular prism on top. So rectangular prism on top above it. It said the diameter of cylindrical base and the width of the rectangular prism is 4. So this diameter is 4 across here, 4 centimeters. Just write the radius one time. Means that the radius is 2. R equals 2 centimeters on this half a circle, a semicircle, right? Semicircle is half of a circle. And this length right here says 4. So this is 4. And then say that's square, right? So that's square. Solid with the rectangular prism. All right, so this is 4 and this is 4. So it's a square on top here. So everything is 4. But I did say that the diameter of the semicircle is also 4. So that's a square right there. But rectangular, because that is long. Let's make sure we understand the dimensions that they give us in the question before we start over. It says calculate the total surface area of the solid. All right, so on the total surface area of the solid, we're going to use the formula we learned in class. Total surface area is curved surface area plus the 2 end areas. Curved surface area plus the 2 end areas. It was a total surface area. All right. And the curved surface area is the perimeter of the end. The perimeter of the end, the distance around the end right here, times the length. That gives you the curved surface area. All right. Let's do this question nice and easy. I like this question. All right. So let's set it up. Total surface area equals curved surface area plus 2 times A, where A is the area of the end of the cross-sectional area. Talking about the area here, so everything is the end area, that total area. All right. This curved surface area is the perimeter of the end, and the length of the prism. The length of the prism is distance between the 2 ends. So this is the L. This is your L. Distance between the 2 ends. All right. And we're gonna add now the 2 end areas to this. Let's work out these things individually and we'll put it in there. What space we have. All right, let's work them out individually. That gives us a total surface area. Let's work them out in red. Now, the perimeter of the end first. Perimeter of the end becomes, let's draw it out, becomes 4 here, so, plus 4 here, so, plus 4 here, so, plus this half of a circumference there, so. Or can see that is 4 plus 4 plus 4. And remember, the circumference is 2 pi r. So the half of a circumference is just pi r. So this is just pi r. Pi times r is this half of a circumference. So the perimeter of the end is 4 plus 4 plus 4 plus pi times 4. This pi times 4 is pi r. Circumference is 2 pi r. Semicircle, half of a circumference is pi r. So this right here, so it's just pi r with a different color. So this calculation right here is pi r. Let me write it as half of 2 pi r. It's half of a circumference, which is 2 pi r, which therefore is just pi r. Half of a circumference is pi r. That's what this is. So put that in the calculator and we get the perimeter of the end. That's going to give us the perimeter of the end. Let's work it out. So it becomes, this is 12 plus, this is 4 times pi, plus 4 times pi. That is 24.57. That's 24 0.57 centimeters is the perimeter of the end. Then the L is the distance between the two ends. That's this length here, so this is your L. Distance between the two ends is the length of the prism. That's the L. The distance between the two ends is the length of the prism. That's the L. So the L is 12 centimeters. Then we need the end area, the area of the end of it now. So we need the A now. Here, so the end area. The A is the end area. All right. So the A in that formula now is the end area, which becomes the area of the square plus the area of the semicircle, half circle. The area of the square is 4 times 4. And the area of the half circle, area of a circle is pi r squared. Area of a half circle is half pi r squared, half pi times 4 squared. That's what the area of this half circle is. Write the formula here. So area of the half circle here is half pi r squared. All right? Or the area, make a mistake, you know. Make a mistake. The radius is 2. I have 4 right here, so the radius is 2. See that? I have 4 here, so but the radius is 2. Let me correct this correction. So this radius is at 2, not 4. I did write on the radius is 2, so I'll recalculate this one. So this one becomes 12 plus 2 pi. That's 18.28 instead. 18.28. This is 18.28. My mistake. 18.28 centimeters. Right. And then the radius is 2 centimeters. So I wrote it down there now. So I don't forget. The radius is 2. So the radius right here said not 4, it is 2. The diameter is 4. The radius is 2. So we're doing this calculation now. So that becomes 4 times 4 plus half, which is 0.5 times pi. Come again. 4 times 4 plus 0.5 times pi times 2 squared. That's 22.23. So this area is 22.28, not 23, 28 centimeters squared is the end area. And then let's plug everything in this now to get the total surface area. Let's plug everything in this now to get the total surface area. So total surface area becomes perimeter of the end, which is 18.2, 18.2, 18.28, 18.28 times the length, which is 12, times 12 plus 2 times the end area. The end area is this 22.28. Write that out and we have the total surface area right now. So it's 18.28 times 12 plus 2 times 22.28. That's 263.92 centimeters square is the answer right there. Nice and easy. But to be careful with the radius for this question, guys. I made a mistake with the radius and put that's 4. Radius is 2. That's why I wrote it down first, you know. Radius is 2. Radius is 2. Let's write it here. So R equals 2 centimeters. Can't give it away. Diameter is 4, so the radius is 2. What good at that? Didn't get it, you need to go and work it over
Yes, sir.
again. So the total surface area. Curved surface area plus the 2 end areas. Just work them out piece by piece. Remember, curved surface area, the perimeter of the end and the length. That gives the area of the side around the side of the object. And then add in 2 end areas to it to get the total surface area. All right, that is the concept that we are using. Because the compound shapes, you have to be careful. All right, let's continue. It says, what is the volume? The volume of our object with uniform cross section, the volume is the end area times the length. So that volume equals the end area is the A that we calculated. See here, this is the A, and this is the L times 12. Easy. So it's 22.28 times the length of 12. That gives it a volume. It's cm cube. So it's 22.28 times 12. That's 267.36 centimeters cube is the volume of that solid. All right. Next part now says, it says the solid is made of gold. So that solid is made of gold. It says 1 cubic centimeter. This means cm cube. 1 cm cube has a mass of this. So 1 cm cube has a mass of 19.3 grams. That's what it says. Remember, this is our total volume. So we can convert this to grams as well by just multiplying by 19.3. All right. So 1 cm cube has that amount of grams. 1 cm cube has that amount of grams, 19.3. It says the cost of 1 gram of gold is this. So that is it. 1 gram cost $42.62. Can't get the cost of the gold. So we need to know what the total gram is in the gold up here. And then multiply by this amount per gram. So we have to do now. So total mass of the solid, total mass is going to be equal to this times this. Because 1 cm cube, look, 1 cm cube is this gram enough. So this amount of cm cube, I call this amount of cm cube, I multiply that by the 19.3 now to get it in grams. Right? So the total mass becomes 267.36 times the 19.3 grams that each gram is. So multiplying those two figures. So it's 267.36 times 19.3. So this is the amount of grams we have. 5160.048 grams. And then 1 gram is for this amount of money. So therefore, this amount of gram is for this times this amount of money. All right, so the total cost. So therefore, total cost is going to be 5160.048 times the amount for 1 gram, which is 42.62. Work that out. So everything multiplied times 42.62. And we get this amount of money. 219,921.2 decimal places, $25.25. That is it. That's the amount of money. Total cost. What do you go to that?
Yes, sir.
Beautiful. Remember, if you didn't get it right, go and do it over again. Send the video, use the video to help you. All right. This question on number 7 is our pattern question. 4 questions to go. It says, at an entertainment hall, tables and chairs can be arranged in 2 different ways as shown in the diagram. So you can arrange them side by side on the long side like that. You can arrange them on the short side like that. So these little things are the chairs, right? These are the tables, all right? So tables and chairs. So you put them long way. It look like you're seating less chairs because you're cutting off the long sides to, as compared to when you're drawing them side by side, you're using up the long side. So it seems to me that you're having more chairs when you put them this way, you're cutting off less. You're cutting off less as compared to cutting off these more when you put them long way, side by side. But anyway, let's see what it says. So something I will just bring your logics to it at the same time. It says draw the diagram for 4 tables in arrangement L. This one. So it's gonna be 4 tables side by side in arrangement L, and then the chairs around it, right? So it's basically gonna be like this: 4 tables side by side. 1, 2, 3, 4 tables. That's what we're gonna have, 4 tables. And then the chairs around it. So on each side, on each of the short side, they have 2 chairs. And on the long side, they have 3 chairs. So I'm gonna put the 2 chairs here. I'm just gonna put these little dots on my chairs. These are my chairs on the short side, 2 on each edge. And on the long side, I'm gonna put 3. 1, 2, 3, and 1, 2, 3. And that's my answer right there. But can I agree to that? That's my figure 4, arrangement L. But good?
Yes,
4
sir.
tables. All right, good. Then we come to this now. It says the number of chairs that can be placed around a given table, a given number of table T. So this is the number of chairs sorry, for arrangement L. This is the number of chairs for arrangement M. And this is the number of tables T. Right? T is the number of tables. For either L or M, form a pattern. The values for C for the first 3 diagrams for both arrangements are shown in the table below. Study the pattern of numbers for each row in the table. Complete the rows for 1, 2, and 3. So let's look at the pattern now. So instead of N, you know, we have T, right? We normally have N in the formula, but now it's T. So this is when there are N tables, when the T equals N. Let's compute this first, because sometimes it helps us to compute up here. So let's see. So this is going up by 4, see? Plus 4, plus 4. So the formula starts with 4n. But the first figure has 10. So 4 times 1 is 4. You have to add 6 to make it 10. That's the formula for this column right now. And over here, it's going up by 6 plus 6 plus 6. That's going up by 6. And so 6n starts a formula over here. 6n starts a formula. First figure has 10. 6 times 1 is 6. You have to add 4. That's a formula for this column right here. All right. Then now, when n equals 4, that's the next shape. You can just continue the trend. So here we're adding 4, just add 4 to this. And that's the next shape. So add 4 to this. Or you can take this 4 and put on the formula. 4, 4 is 16 plus 6 is 22. Or you can just add 4 to this and get 22. You can just add 4 to this plus 4. Here you can just plus 6. Because this one going up by 6. That will make this 28. Or you can take the 4 and drop it on the formula right here. 6 4 is 24. 24 plus 4 is 28. So whether you want to use the formula or just add the 4 because it's the next shape. That's because that's the next shape. So you can continue the trend. Then for this line, this is 130. So you're going to equate this to 130 to what the n is on this line. All right. So let's work it out over here. So on this line, we're going to put the formula equals 130. Let's see what the n is. So we're going to put the formula of 6n plus 4 equals 130. Subtract the 4 first. We're going to get 6n equals 126. That's right. And you divide by the 6, you're going to get n equals 21 when you divide by the 6. So n equals 21 right here. Then to find this, I'm going to drop the 21 on this formula. So it's going to become 4 times 21 plus 6. That becomes 84 plus 6. That's 90. I'm getting 90 right here. Gotta go to that. Let's just double check and make sure my brain is tired. 4 times 21 plus 6, 90. That's correct. All right. So that basically finishes the table right here. Nice and easy. Very good. By the right so far?
Yes, sir.
All right, good. It says Leon needs to arrange table to seat 70 people. So it means that the number of chairs must be 70 for a birthday party. If you're seating 70 people, you need 70 chairs. Which of the arrangement LRM will allow him to rent the least number of tables? They want the least number of tables. So remember, N is the number of tables. So you want to know which of these formula and give it the lowest value. Now it is supposed to be, common sense tells you that it is supposed to be this one, arrangement L, because arrangement M, because you're wasting less space, right? That arrangement allowing you to use more chairs, right? So that's what common sense would tell me, because you see, you're cutting off less space on this one. Here you're wasting more space on the arrangement. So this looks like the better arrangement if you want to use more chairs. M. But let the mathematics work it out for us. Let's work it out. So basically, you want to know which one of them will give you the greater N. N is the number of tables when the total number of chairs is 70. That's what it is. All right. So for arrangement L, it is 4N plus 6. That must be 70. And for arrangement M, it is 6N plus 4. That must equal 70. All right. So that's what you're working on. So the N, 4N for this one is equal to subtract 4, you get 64. And then N equals 64 divided by 4, which is that? Back 64 divided by 4. That's 16. So N equals 16 and 16. And for this one, you subtract that again. Now you get 6N equals subtract 4 now. You're gonna get 76. No, not 76, 66. Subtract 6 to get 66. And then N equals 11. You see, arrangement L, arrangement M use less chairs, see? Less tables, arrangement M. So see, which one use the least number of tables? Arrangement L, arrangement M. So M uses less tables. So nonsense. So which arrangement LRM allows him to rent the least number of tables? So he can use the 11 tables to seat 70 persons as compared to where you say need 16 tables in arrangement L. Because he's wasting the space in arrangement L. Because he's joining it alongside. He's basically being able to accommodate less chairs in arrangement L. It's just that this might need a longer length of space as compared to this one. I put in the table a long way, but it don't matter. The space in the hall is a restraint. But that is it. So arrangement L uses less tables. So that's the answer. Arrangement L. That's a justification. So here you're using 11 tables to seat 70 persons. Here you're using 16 tables to seat the same 70 persons. So arrangement M. But go with that?
Yes, sir.
But okay?
Yes, sir.
Good.
Yes, sir.
All right, number 9. Number 9 says, a rental company has X cars and Y minivans. X cars and Y minivans. It's a linear programming question. Let's see that. It said the company has at least 8 vehicles. The word vehicle is taken to mean the sum of the cars and the sum of the cars and the minivans, right? So let me write it out. We have X cars. Let me write it out here. So we have X cars. We have Y vans. Let's call it vans. There are minivans. Let's call it vans. The vehicles means the total. So I must write 3 inequalities. So this information that there must be at least 8 vehicles. At least means that amount or more, 8 or more. So it means that X plus Y, total vehicles, must be greater than or equal to 8. At least 8 means 8 or more. Must have at least $10 to do something means that you need at least you need 10 or more dollars. Don't let the word least cause it to write the less than sign. At least 8 means 8 or more. So the total number of vehicles, which is the number of cars and number of vans, must be 8 or more. That's first inequality on that statement. Right? Next part says the number of minivans, which is Y, must be less than or equal to the number of cars. Second inequality, the number of minivans, which is Y, must be less than or equal to the number of cars, which is X. That's the second inequality right here. This statement. Next one says the number of cars must be no more than the no more than 9. No more than 9. 9 or less. Can't pass 9. The number of cars, which is X, must be less than or equal. Can't be more than 9. 9 or less. That's your 3 inequalities. Let's say right 3 inequalities. See them here. That's it. 3 inequalities. Very good? But okay?
Yes, sir.
Yes, sir.
And let me space them out. As remember, I'm going to write what each one means in terms of the graph. You don't need to write it, but I'm doing it for the class. We represent each one on the graph, right? When we get to that stage, we write. Down here now, it says, a car can carry 4 people. So number of people in a car is 4 times X. So X cars, right? So number of people in a car is 4X people. 4X people in cars. 4X people in cars. Minivan can carry 6 people at 6Y. Minivan can carry 6Y, so that's 6Y. So the people equals 4X in the cars plus 6Y in the vans. But understand that? That's the people that you're carrying. Because each car has 4 and it's X vans, X cars, and it's 4 persons in a car, so it's total number of persons in cars. There are Y vans and there are 6 persons in a van, so it's 6Y is the number of people in the vans. So there are at most 60 persons going on a trip. At most. At most means you can't pass 60. Less than or equal to 60. So the total number of persons must be less than or equal to 60. So you said this has to be less than or equal to 60. Simple as that. Right? It says, taking on a tour, show that this is true. So the total number of persons must be less than or equal to 60. So it's gonna be that 4X plus 6Y, that's the total number of persons, can't be more than 60. It has to be less than or equal to 60. Divide this through by 2, you're gonna get 2X plus 3Y less than or equal to 30, which is what this is shown. That is the answer right here. But I got that? Or divide through by 2.
Yes, sir.
All right. Continue. It says, on the grid below, plot the 4 lines associated with inequalities and shade and label the region that satisfies all 4 inequalities R. So must shade and label. So join those lines now. So let's go. We're going to represent each one. Let's put them in red. Now, what I'm putting in red, you don't need to do. I'm just doing it for the purpose of the class so you can know how you represent it. So this one, first. Remember, when the Y on the left side of the inequality is positive, the inequality here, when the Y is positive as it is now, the greater than means above. Inequality in a graph is about being above or below a line. So you want to know whether you're above or below the line. Since the Y on the left side is positive, the greater than means above. So you're going above this line. The line is going to be a solid line because the equal is a part of the inequality, meaning points on the line are also valid. So you're going to be drawing a solid line. And the line you're drawing associated with this inequality, you just replace this with an equal sign to get the line that you want. It is X plus Y equals 8. That's an easy line. call it the x plus y line. It crosses the y-axis at 8 and crosses the x-axis at 8. So it passes through 0, 8 and it passes through 8, 0. So 0, 8 on the y-axis, 8, 0 on the x-axis, the x plus y line. And this one is another easy line. Again, the y on the left side of the inequality is positive. So the less than means below. You're going below this line now. You're going below. The equal is a part of inequality, so you're going to draw a solid line to indicate that points on that line are also valid points. And the line you're drawing is the line y equals x. And then associated with this one, you repeat that with an equal sign, and y equals x. That's it, like the easiest line to draw, y equals x. Pass through points where the x and the y value is the same. So it pass through 0, 0, and pass through a point, for example, maybe like 8, 8. And pass through like 4, 4. Pass through points where the x and the y values are the same. And this line now, when there's the x alone, less than means below. So you're going below this line. And it's going to be a vertical line. The equal is there. And the inequality is going to draw a solid line again. Meaning the line is a valid. Points on the line are also valid. The line associated with this one is x equals 9. Changes to an equal sign. X equals 9. And x equals 9 is a vertical line passing through 9. That's what x equals 9 is. X equals 9 is a vertical line passing through 9. All right, that's that. And then for this one down here, again, let's analyze it. The y on the left side of the inequality is positive. See it positive there? The y value is positive. So the less than means below, going below this line. The equal part of the inequality is going to be drawn a solid line. Points on the line is also valid. Points on the line are also valid. So I'm going to be drawing a solid line to show that. The line we're drawing is one associated with this inequality. Just replace this again with an equal sign and get the line that you're drawing. That's 2x plus 3y equals 30 we're going to draw. All right. And we're going to want to get 2 points on this line quickly. 2 points on this line quickly. How do we get 2 points on this line quickly? Watch this now. You put on 2 points like this. One of them will give an x value of 0. Other one will give a y value of 0. I want to work out the value for here now. How you work it out? When the x value is 0, you put x value here is 0. This will be gone. When x is 0, that will be gone. You're going to be left with 3y equals 30. And x equals 0. 3y equals 30 divided by the 3, the y equals 10. That means that 10 is the y value. And that is the case. And then for this point, you're going to put the y value is 0. You're going to put the y value is 0 right here. When you put the y value equals 0, 3 times 0 is 0. This will be gone. You're going to be left with 2x equals 30 when the y is 0. If 2x equals 30 divided by the 2, x is 15. That means that when the y is 30, when the y is 0, the x is 15. So these are 2 points on that line, on this line. 0, 10 on the y-axis, 15, 0 on the x-axis. This one is on the y-axis, this one is on the x-axis. 2 points. All right? So that's how we're going to draw those lines now. So let's go now. Let's put them on the graph. Draw them in blue. So the first line was x plus y equals 8, right? Let's put that on the first. So that one passed the y-axis at 8 up here and passed the x-axis at 8 down here. So it passed through a point where the x plus y value is 8. So it passed through these points first. I'm just going to draw a straight line connecting those 2 points. That's it. Let me extend it down. I must always label the line with the equal sign. This is x plus y equals 8. And they do want above or below this line. We want it above this line. So I'm going to put an arrow up. Remind me that I want above that line. So you put an arrow pointing up. So the region that I want is above this line. Next one is y equals x, right? See there, y equals x, and I want below it. So y equals x right passes right down the middle of the graph. So y equals x passes through 0, 0, it passes through 4, 4, and it passes through 8, 8 up here. So 8, 8. And it passes through 10, 10 here. So I'm not going to draw a line passing through all those points. Let's draw that again. That's the line y equals x, and I want to go below this line. Put the arrow pointing down. So the region that I want right now is somewhere in here. Above this one and below this one. All right? That's what I want. So let's continue putting other lines first. All right? The next line we're going to draw is the line x equals 9. X equals 9 is a vertical line passing through 9. So it's a 9 here. I want a vertical line passing through 9. So I'm going to draw it like this. All right, let me draw it again. Good. That's my vertical line passing through 9 right now. Label the line with the equal sign. X equals 9. And I want below this line, meaning I want to the left of this line. Below a vertical line is to the left of it. See, below that line. Below the vertical line is to the left of it. Because over here, x values are less than 9. So the region that I want is somewhere inside here right now. And I finished it. I have one more line to put in, which was this one, right? This line. And that line was said, cross the y-axis at 10 and cross x-axis at 15. 0, 10 is on the y-axis, and 15, 0 is on the x-axis. So 10 on the y-axis, 15 on the x-axis. So it's 10 on the y-axis up here, there 10 on the y-axis, 15 on the x-axis out here. I'm not going to draw a straight line through those 2 points with this device, right? So starting at this point, I'm going to come right through here. That is it. So this line now is a line, what is it again? It is 2x plus 3y equals 30. This line is 2x plus 3y equals 30. 2x plus 3y equals 30. I want it what? Below that line? Or below that one, right? Below, right? Below. So going below this line as well. Arrow pointing down. So it means that the region that I want, let's zoom in on it now. It's in a different color. It is below this line, above this line, and to the left of this line. Notice there's a section here on x-axis. Above that, there's no line there, but you expect number of vans and number of cars to be more than 0, so above this line as well, 0 or more. So let's shade the region that we want and put our R in it. So I'm going to put R in here. That's the region that we want. And let's shade it in a different color. Let me use green or something like that to shade it. So inside here, it's a shade and label. They usually just ask us to label alone, but it's a shade and label. So this is it. I'll put my R in there. That's it, guys. What go to that? It's R, them so much label it here. Label it R. That is it. What good?
Yes, sir.
That's my reason. Beautiful. Now, remember, these questions, the vertices are always important. These vertices. So this is a vertex right here. That's a vertex right here. That's a vertex right here. Right? Is a vertex. That's another vertex right here. This is another vertex right here. Right? 5 lines, 5 vertices. Right? 4 lines. There are 4 lines, but there's no line there. That's another line. That's a line as well, and the x-axis another line. So it's 5 vertices. All right. So basically that is it. So that's what they want us to do. So I've drawn the graph. Then finish everything up here. Yes. Down here now it says determine the two combinations for the minimum number of cars and vans that can be used to carry exactly 60 persons. So if you want to carry exactly 60 persons, means that you're on the line for 60 persons, which was the 4x plus 6y equals 60. You're on that line because you're carrying exactly 60 persons. So 4 times the number of persons in a car, four persons per car where there are X cars, 6 persons per van where there are Y vans. That total must be 60. So you're on this line. This line was 2x plus 3y equals 30. So you're going to the vertices of this line to get minimum. And it's 2 combinations. That's where you're gonna be on this line for exactly 60 persons. So if you got exactly 60 persons, you're gonna be on the 60 persons line. And you go to the vertices. So what are the vertices? So let me hear the mark them out for you in red. So it's the line X plus the line here, so this is the line that we're on for exact 60 persons. For exactly 60 persons or people, you have to be on this line. When you're carrying less persons, you go below it. Like in the shaded region, you're carrying less than the 60 persons. Remember, you can't carry 60 or less. So if you're going to carry exactly 60, you're going to be on this line. And the 2 combinations that you can carry persons are the vertices. Right? So let's call this vertex A. Let's call this vertex B. Where A is the point, what is it now? A is the point 6, 6. You can carry 6 and 6. 6 cars and 6 vans. Or B is 9 and 4. You can carry 9 cars and 4 vans. 9 and 4. That's a combination. 6, 6, 9, 4. That's a combination. That's 6, 6, 9, 4. So that's at point A, 6, 6. All right, B, 9, 4. And this one is 6 cars and 6 vans. And this one is 9 cars and 4 vans. Can carry exactly 60 persons. But good, go to the vertices, work out maximum minimum of anything. Determine the 2 combinations for the minimum number of cars and vans that can be used to carry exactly 60 persons. You're on the exactly 60 persons line. Says no. The company charges $75 for a car and $90 for a van. All right, to rent a van. Show that the minimum rental cost for this store, see the store that they're talking about on D. This store, the tour carrying 60 persons. For this store, $990. So in other words, what's going to be the cost of those combinations? Which one of them is a lower one? These are the 2 combinations on which you can carry 60 persons on this tour. This is the tour of 60 persons, we're talking about. So we're talking about these 2 combinations. All right. Now let's what they said now. So the cars is $60 for a car. So the money for the car is not 60, $75. So the money for the car is 75 times X plus there were Y vans, right? And it's $90 per van. So the money for the van is $90 times Y. So the total charge is this. Total charge is that combination. Total charge. Total cost. So the total cost formula is going to be $75 times X cars plus $90 times Y vans. Now if you use combination A, use A plus 6, 6, then the total cost would be $75 times 6 plus $90 times 6. We're using 6 and 6. I want to work out what that is, right? And if you're using B, which was 9 cars and 4 vans, then the total cost would be $75 times 9. So $75 times 9 right here, plus $90 times 4. 4 will be the number of vans. And record that one and see which one is lower. I'm going to say the 990 is the lower one. Let's work them out. So the first calculation here is 6 and 6. So it becomes 75 times 6 plus 90 times 6. That's 990. Total charge of $990 if you use 6 cars and 6 vans. Then down here now, you can go for 9 cars. So it changes to 9. 75 times 9 plus 90 times 4. That charge would be 1035. So clearly see that this one is a minimum charge. This one is a minimum cost to carry 60 persons. That one. Therefore shown. What is that? So you can carry 60 persons using this combination. With this amount of money you're going to have to spend. You're going to spend $990. Or if you use this combination, you're going to spend this amount of money. So if you want to reduce the amount of money that you're spending, the best combination to use is 6 cars and 6 vans, and can still carry those 60 persons on the floor. And you would only be spending $990. It's likely to be a nice SB. That finishes that question, guys. Everybody good? All right.
Yes, sir.
Good to go.
Yes, sir.
Good. Let's go to the next question. Circle theory. Let's go. This question says H, J, K, L, and M are points on a circumference of a circle with center O. MK is a diameter. So once you see diameter here, you must be remembering angle subtended by a diameter is 90 degrees. So right here before you even start, you know that this angle here so is 90 degrees right here. So angle subtended by this diameter is 90 degrees. All right. So before you even start, you know that this angle is 90 degrees right here, just in case. And look here, this angle is 90 degrees. You're thinking as you're going, and this angle down here you can know as well. This angle is going to be 90 degrees minus 38. Because those two angles are complementary angles at 90 degrees. All right, so as you read, you're figuring out some stuff as you go, just in case you need, right? Then it says, bam, 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 it says these two lines parallel. It says the diameter is parallel to HD. So once you see parallel lines, you're thinking of Z angles. And the parallel lines are indicated. But you can see the screen, see me and hear me?
Yes, sir.
All right, good. So these two lines are parallel. So once you have those parallel lines, you're thinking of your co-interior angles and your Z angles. So let's look at it now. Things that you should be considering. So this line and this line parallel, right? But firstly, they are joined head to tail by this line. And so you have alternate angles. So this angle and this angle is equal. So the angle right now in there, so it's 38. Z angles are equal. Then if you go for your co-interior angles, remember we said we could find this angle from this. So if you find this angle, then these two angles now are up to 180 because they are joined. Those two parallels are joined here. So you have that U angle there, so the co-interior angles. So if you know this angle, you can know this one is 180 minus that. All right, because those two angles now are up to 180 degrees, co-interior angles. Also, if you join this end up here, then these two angles, this and this, again, they add up to 180 degrees. Co-interior angles again. Right? So you're kind of looking out for those things as you work. All right, you're looking out for those things as you work. All right, and then it says MJ and LJ are equal. Now, those are indicated with these lines. It means then that this triangle is an isosceles triangle. This triangle is isosceles. That's an isosceles triangle. And so this angle down here, all of that angle is equal to all of this angle over here. Those two angles equal. They are opposite equal sides in the isosceles triangle. So again, you're looking out for that again. These two angles equal. All right. A lot to unpack, a lot to remember. But let's go. And you could be putting in some of the angles as you get information. As soon as you figure out, you could be putting them in as you read and so on, right? Rather than wait to start answering the question. You could be putting in some of the angles as you read. As you discover, so this is 90, and you put in what this one is here. So same time by putting 90 minus 38, write it in, and then you know that this angle and this angle equal because they are subtended by this chord, angle in the same segment. This angle subtended by that chord, same chord subtending this angle over here as well. Same chord subtending this angle. So these two angles are equal, this one and this one. So you're going to be putting in some of them as you go. All right, but let's answer the question in the order that they give it. It says, explain why angle HGM is 38 degrees. Where's that angle now? I think it's the Z angle, you know. HGM. H to G to M. This angle. It's alternate angle with this one. Alternate angles are equal. Right? That's right. Alternate, which we call Z angles, are equal. And let's put it on the diagram. So this angle in here says 38 degrees. Let's put it on. In here says 38 degrees right here. All right. Z angles up here, so equal. What else? Angle MJK is 90. Angle MGK here is 90. Because subtended by this diameter. Angle subtended by diameter is 90 degrees. I'm going to say that. Angle subtended by diameter is 90 degrees. And I'm going to put it in the same time as well. So the angle right here, so all of this angle right here, so it's 90 degrees. Everything here, so it's 90 degrees. Between this line and this line is 90 degrees. They are subtended by this diameter. So that's right. Angle subtended by diameter is 90 degrees. Angle subtended by diameter. What's the name of that diameter? That diameter is MK. By diameter MK is 90 degrees. That's the diameter rule. All right, that's the reason why it is 90. Next question. It said determine the value of each of the following angles. Show detailed working where necessary or appropriate. So then asking for reasons. Just wanted to just calculate them, right? So show detailed working. But my people can give some reasons as well. First angle I want is MJL. Let's see what that is. MJL. No. MLG. 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 That's this angle right here. I was telling you that this angle is subtended by this red chord. Oh, you know, let's look at it again. They're asking us for this angle, right? Right here. To find the arc or chord that is subtending that angle, you go back along the sides until you reach the circumference. Don't stop until you reach the circumference. So you subtend it from this point and you go back again down here. You reach the circumference, it is subtended from this point. You look for what is subtending it and look what that thing is also doing. It is this chord that is subtending it. I could say this arc. We normally work with the chord first. Right? When you don't show a chord, you work with the arc. But since I show a chord, let's work with the chord. What else is this chord subtending? That chord is also subtending this angle, the circumference, draw it in red. It's also subtending this angle at the circumference right here. So these two angles equal, them two angles there, them equal. All right? But then this angle right now is complementary with this angle up here, so because this angle is at 90. Right? So if you find this angle, this is equal to the same angle. So basically that's what we're gonna tell the exam. And this angle is 90 minus 38, that triangle. Those two angles are up to 90 degrees. But you understand what I'm saying? Just making sure. But you understand that? What to go to
Yes,
that
sir.
explanation? All right, good. So it's gonna be same segment rule, right? Same segment rule. So when I write this angle here so first, this angle here so first, this one. This angle here, 90 degrees minus 38 degrees. Which works out to be 90 minus 30 is 60 minus 8 more is 52. So therefore, this angle is also 52. This angle is also 52 degrees. Same segment. Angle in the same segment are equal. This angle is also 52. Same segment rule. All right, so let's go and write that now. So we're gonna tell him that this angle that we want is firstly equal to this one over here, which is MKG. It's first equal to MKG. It's equal to angle MKG. And that's because angles in the same segment are equal. That's why this equal this. And then this angle now is equal to 90 degrees minus 38 degrees, which is 52 degrees. And this one now, because total angle in this triangle is 180. And this one is already 90. So that's why these two are up to 90. Right? So when I say total angle in triangle, MKG is 180 degrees. I already worked out that this one was 90. They told us that it was 90 already. All right, so we're gonna say total angle in triangle MKG is 90, is 180 degrees. This is because total angle in triangle MKG is 180 degrees. And one of them was already 90. That's the reason. What to go to that? So it's 52 degrees.
Yes, sir.
Yes, sir.
Beautiful. Next part, another one is LJK. LJK, that's what angle that is. Angle LJK. So LGK. So they're talking about this angle here. I want next. Let me use the purple for that one. They now want this angle right here. L to G to K. That's this angle right here they want now. Now again, find what is subtending this angle. So I'm gonna come back here. So you use the circumference here. Come back along this side. So you use the circumference here. There's no chord across here now, so it is being subtended by this arc. I'm going to mark out in red. Now, that same arc is subtending this angle that I'm going to mark out in blue up here. Same arc is subtending this angle up here. Up here. This angle. What can I say that? So these two angles equal, same segment rule, right? So if we can find this angle, then we know this angle. Now, how can we find this angle? Remember now that this triangle is isosceles. Let me erase this now. Let me erase this. No, not that. Erase this. So we are saying that these two angles equal, right? This one and this one equal, right? Same segment rule. All right. So how can we find this second angle inside here? So now, remember now that this angle, all of this angle here, is equal to this angle down here. Why is that? Because that's an isosceles triangle. It's an isosceles triangle. So the angle here and the whole of the angle here equal. So everything up here is up to 52 degrees. And this part of it is 38. So the little purple section, little purple angle right here, so that we want now. This little purple angle right here is 52 degrees minus 38 degrees. But I can appreciate that because if this is 52 and all of this is 52 as well because of the isosceles triangle. And this part of that total angle is 38. Then look a piece in here that we're trying to find is 52 minus 38. But I get that?
Yes, sir.
Yes, sir.
Yes, sir.
That's 14. That's 14 degrees. So it means that this angle in here is also 14 degrees out of same segment rule. Why did I say that, right? So let's go now and see how we present it. We want to first say that this angle that we want is equal to this angle up here, which is angle LMK. Angle LMK. The angle that we want is equal to angle MLK. LMK. And LMK. Tell examiner how we get it. So the angle that we want down here is equal to angle MLK. Because of same segment rule again, right? That's because of same segment. Same segment again. And this angle is actually 52 degrees minus 38 degrees, which is 14 degrees. Why is that? Because the triangle is isosceles. Two angles are equal in the isosceles triangle. The angle here and the angle here is the same. The isosceles triangle. So it's MJL is the isosceles triangle. Because triangle MJL is isosceles. So the two base angles are equal. Right? So I'm gonna tell them which two angles equal. So the angle equal 52. So angle JML is 52, like the one down here. So angle JML is 52. Isosceles. Therefore, angle JML equals 52 degrees. So the whole thing is 52 degrees and piece of it is 38. And the piece that is missing is 14. That is it. All right. Next part. So I think this question I don't need no reason, guys. You just need to do the calculation and write the answers, Because they didn't ask for an answer. You know to as well by this 1 mark for that and so on. So I just want you to calculate them, but I'm giving you the reason still. Next one I want is angle GHM. GHM. That's up here. GHM. That's this angle up here, so. Alright, so now we're trying to find this angle. Well, this angle is across from this angle in this quadrilateral, the cyclic quadrilateral. So the cyclic quadrilateral here. The opposite angles are up to 180 degrees. So I mean that this angle inside here that we want is 180 degrees minus the 52 degrees. Right? which is 128 degrees. Opposite angles in a cyclic quadrilateral are supplementary. That's why. All right, so that is 180 minus 52. This angle equals 180 degrees minus 52 degrees, which then is 128 degrees. That's because opposite angles in the cyclic quadrilateral are supplementary. 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 Which means that they add to 180 degrees. No, I don't think this was required. They just want to report the answer based on this question because they didn't ask us to give any reason. Just calculate it for the instruction. Say determine each of the following. Show detailed working where appropriate. Just calculate. They never ask for any reason. The reason part of it was up here to explain the reason. So down here they didn't really need any reason. They just wanted to calculate. But I'm giving the reason still in this solution. Alright. This is only 1 mark for that. So let's calculate the angle and get a mark. 128 degrees. That finish. Part B now is our bearings question. So the north lines I know is bearings. Question says, from port L, that's from here, ship R is 250 kilometers, 250 kilometers on a bearing of 065 degrees. So the bearing of this direction up here is 265 degrees, 065 degrees. So it means it's clockwise from this north line right here is 065 degrees. Let's put it in from now. As I work it out, let's put it in. So the angle clockwise here is 065 degrees. All right. It says ship T is 180 kilometers, so 180 kilometers here from L again, and that one is on a bearing of 148 degrees. So again now, the bearing of this direction down to T, that bearing is 148 degrees. So again, it's from this north line clockwise down to this direction is 148 degrees. Let's put that one on the diagram again, neatly. Let's put it down here. So the bearing around here, so now clockwise around to here. That one now is 148 degrees. So it means then that the angle in between here, so is the difference between these two angles. Simple as that. 140 minus 65. All right. So that is what 83. 148 minus 65. 83 degrees. So this is 83 degrees. Let's put down from now. I might ask you for it, but just put it down from now. As you read, I have the information, populate the diagram. That's information. This information is illustrated in the diagram below. Question says, complete the diagram by inserting angle RLT. So RLT is this angle that we'll just put in here. That's 83 degrees. So put on the diagram, 83 degrees. So this angle is 83 degrees. And we have written it on the diagram. It is 83 degrees. That angle is 83 degrees. All right. Then it says calculate RT, distance between the two ships. So we're going to be working in this triangle, that's a right angle triangle. We have two sides and an angle between them. That's cosine rule. We're going to be using cosine rule. Find this side over here. So cosine rule. Let's tell the examiner cosine rule. Cosine for the RT. Remember now, cosine rule starts out like Pythagoras' theorem. So it's going to be RT squared equals this side squared plus this side squared. That's 180 squared plus 250 squared. But it's not part of the system, so if you subtract a piece, so you subtract twice the product of the two sides, 180 times 250, and then you cosine the angle between them, which is 83 degrees. Instead of squaring it here, as always, we can cross the square and square root this side instead. So we'll do the calculation in one step, and then put everything in the calculator one time. I get RT equal. Let's put this in the calculator for one calculation. Right? So it's going to become the square root of 180 squared plus 250 squared minus 2 times 180 times 250 times cosine of 83 degrees. Make sure you put everything in the calculator, right? That is it. That's 289. All right, 289.7. Let's call it 290. Let's just call it 290. 290 3-digit kilometers. And as I find it, put on the diagram there. So 290. So this side is equal to 290 kilometers. I know that we have this pair of angle and side opposites other in the triangle. We can use sine rule going forward to find whatever we don't know. The only thing we don't know in this triangle now are these two angles. We can use sine rule to find any one of them. All right, we know the three sides and we know this angle. So to find these two other unknown things, we can use sine rule to find any one of them. All right, let's see what else I want us to do. I want us to find the bearing of T from R. I must always note the bearing direction that you want. It's from R to T. So on the direction R to T, the direction R to T. That's the bearing that you want. R to T direction. Put on the diagram. R down to T. So the bearing that you want is of this direction, R down to T. Alright? So find that bearing. You want to look at this from position, and I always say when you want the bearing from this point, the angle inside the triangle at this point will more than likely play a part in the calculation. So therefore, I'm going to mark it from now and call it alpha and see how it plays a part. This angle in here will more than likely play a part in the calculation. But I have to show that bearing angle that I want on the diagram and see how I calculate it. Alright, so at the front position, I'm going to put in my north line here. Choose the purple or the red. Put in my north line. I want the bearing of this direction down here, right? So I'm putting my north line here first. Meter my piece. Put in the north line here. I want the bearing of this direction down here. So it's a clockwise angle from the north line all the way around to here. That's what we want, that angle we want. Alright? Now we're going to find that angle now. Now, let's zoom in on it. It's straighter. That's the bearing of the out. The bearing of this direction is this angle. Alright? So to find that angle, we know that total angle around this point is 360. And we can find this angle inside here. Alright, we can find that angle inside here. That's not the only way to do it still. Let me see, come down here, go up here, come down here. Can do it another way too, now look. We can break this angle, the vertical line, and then all of this will be 65. And then to find alpha, it will be 180 plus the difference. But I think the easy way to do it really maybe is to just find the angle in here. And the total angle around the point is 360. Now, with a different color now for this part. Remember now that in this line down here, in this angle and this angle Two of them add up to 180 degrees. They are co-interior angles. This angle is already 65 degrees right here. So this angle up here is 180 minus 65. Co-interior angles. Everybody must know how to do this thing. Alright? You must know how to do that thing. And I ask this thing all the time. Alright? So this angle inside here, over here, is co-interior with the angle down here. They add up to 180. So it means that this angle is 180 degrees minus 65 degrees. This angle up here. 180 minus 65, that's 115. So that's 115 degrees. This angle is 115 degrees. And then this angle, therefore, that we want, the theta, the bearing angle theta, is now equal to 360 minus the 115 and minus the alpha. We're going to have to find alpha. It is 360 minus the 115 over that space. Shift this down somewhere. Shift off it, right? It says 360 minus 115 degrees and then minus the alpha. We're going to have to find the alpha using sine rule. All right? And use sine rule for the alpha. Let's do the calculation down here. All right? So the alpha, sine rule for alpha. It's going to be the sine of alpha over the side opposite the alpha. The side opposite the alpha is just 180. Equals sine of the angle that we know. The angle that we know is 83. Over the side opposite the 83 is that 290. And they're going to take the 180, multiply it up here, and then take the inverse sine. So the alpha is going to be sine to the minus 1 of 180 times the sine of the 83 degrees over the 290. That's going to give us our alpha. All right, so let me copy these things down now. So we were doing the work down here. So first, the bearing of this is the theta angle. And the theta is 360 minus 115 minus the alpha, right? That's what we said. Minus alpha. 360 minus that and minus the alpha. I'm going to use sine rule for the alpha. Sine rule for the alpha. For the alpha. And it is this calculation that we just did right here. Sine rule for the alpha, this calculation that we just did. This calculation that we just did. Put that and paste it down here. Change that to red. And then work out what alpha is. Alpha equals, work it out here now. Alright, the calculator. So what we get comes sine to the minus 1 of a fraction, and the fraction of 180, and the sine of 83 over, that's 290, becomes 38 degrees. 38 degrees. Instead it's 38 degrees, and calculate the back right here and get the theta that we want, the bearing angle. So theta becomes 360 degrees minus 115 degrees and minus 38 degrees. Whatever that works out to know is your bearing. So it's 360 minus 115 minus 38. That's 207. degrees, and that is the answer. Right? That is it. So guys, just need to practice this thing, the same calculation all the time. As you can see, the same calculation, different values all the time. So you really have no business having a problem with this. Same way the calculations are all the time, just with different values. All right, buddy, okay with that? Buddy, good?
Yes, sir.
Yes, sir.
All right, one last question. And then we're done for the day. All right, let's go. Major C is transformation. Let's go. So question gives us this transformation measure, and the C they should know, but they tell you, they're helping you, they tell you. It says a rotation 90 degrees anti-clockwise about the origin, but you should know on sight. Soon as you see, you should know. That's what I want to prepare for the exam. And this one is the y equals minus x reflection matrix. See there? Reflection in line, y equals minus x. See there? Reflection in line, y equals minus x. You should know that on sight. It says, write the coordinates of P prime, the image of this point, after undergoing a rotation 90 degrees anti-clockwise about the earth. So we're applying this matrix to this point. So all we have to do. So P prime. So P prime is going to be equal to this matrix times the point, which is 0, minus 1, 1, 0, times the point 7, 11 is the point. And work it out. So remember using the root of the first matrix times the one column. Answer is going to be a column matrix with two values there. Let's put them in red. So the first value here is in the first row in the one column. So to get it to multiply this first row with this one column, easy. 0 times 7 and minus 1 times 11. That gives you negative 11. So this is negative 11. Then the value down here is the second row with the one column. So the second row with the one column. So it's 1 times the 7 and the 0 times 11. 1 times 7 is just 7. So it becomes a 7. It means that the coordinates of P prime, that's the coordinate, is minus 11, 7. That's the answer. But good?
Yes, sir.
But okay?
Yes, sir.
Next part says T, the combined transformation A followed by B. So determine the elements of the matrix represented by T. So T, the combined transformation A followed by B. Number A followed by B is B times A. Second one times the first one. So really T is equal to BA. So T equals the B matrix, which was the 0, minus 1, minus 1, 0, times the A matrix with 0, minus 1, 1, 0. Right? Multiply the second one by the first one. So just multiply these two matrices now. So T equals a 2 by 2 matrix. Let's write it out in red. Same way, using the rows of the first matrix, using the rows of the first matrix with the columns of the second matrix, we get these four values. The first value here is the first row, first column. So using this first row with this first column. So it is 0 times 0 and minus 1 times 1. That becomes a negative 1 right here. And this value is in the first row, second column. So I multiply this first row with the second column. So it's going to be 0 times 1 is 0. And minus 1 times 0 is 0. So this value is at 0. And the value down here is in the second row, first column. So I'm multiplying this second row with this first column. So it's going to be minus 1 times 0 is 0. 0 times 1 is 0. So this value is going to be a 0 again. Right here. And last one down here is the second row, second column. So multiplying this second row by the second column. So -1 times -1 is a +1. And 0 times 0 is 0. So it becomes a +1. That is a matrix. That's a T. And that matrix is a y-axis reflection matrix. You should know that that is a y-axis reflection matrix with a -1 up here. Y-axis reflection matrix. So describe the transformation T for the reflection in the y-axis. A reflection in the y-axis. I could say line x equals 0. Remember, the y-axis is the line x equals 0. That is it. Y-axis reflection matrix is one of the first -1. You must know those things on site. When they want to do with an exam, know what you need to know. I gave you the list of matrices that you must know. So that those are the same matrices coming up in the exam, in the questions. All right, this one down here. It says 2 by 2 matrix C is defined as this. K is a scalar quantity, and K is a constant. Determine the value of K if C is singular. If C is singular, remember, it has no inverse. Because the determinant of C is equal to 0. When the determinant is equal to 0, it means that this diagonal product is equal to this diagonal product. That's what happens. That's when AB equals CD. Not AB, AD. AD. But this is A, B, C, D. So AD equals BC. That's when AD equals BC. So AD, this product is 3 times 4. So 3 times 4 comes equal to this product is 6 times K. 6 times K. So 12 equals 6K. Therefore, K equals 2. So this product is 12. And this product, for this product to be 12 as well, the K has to be 2. So K equals 2 to make it singular. But go to that. When the determinant
Yes,
is 0,
sir.
the two
Yes,
diagonal
sir.
products are the same. Right? Next question. Is vectors. It says in the diagram, O is the origin right here. OX is U. This is the vector U. OY is V. That's the vector V. It says OX and OY are extended so that X and Y are midpoints of OA and OB. All right. So this is the midpoint of this line. And this is the midpoint of this line. It means then that this vector and this vector is the same. So it means that little vector up to here is also U. This is also a vector U just like this. And then this vector out here is the same as this vector V. So this vector out here is also V. So the whole of this is 2V. The whole of this is 2U. Right? If you want. So we can know those as well. Question said, must express BX in terms of U and B. So BX becomes OX minus OB. And I can use that because I know all the position vectors. The OX is U minus the OB is 2V. Simple as that. All right, to go from B to X, see there is minus 2V plus U. I can look at it this way. It is a U, which will take you up to here. That's a U. Right, same as this length. And then you come back 2V. That's minus 2V. Minus 2V. All right, take you from B to X like that. So you know that that is correct. It's not complicated. This one is very easy. Next question, next vector I want is given that YA and YX intersect at M and BM is 2MX, express BM in terms of U and V. Let's see what that is. YA and BX is put on diagram so we can see what they're talking about. YA and BX. Let's draw them in. YA is the line from Y to A. So this line up here. Let's draw it over. And BX is the line from here to here. They intersect at the point M. What did they say? They say that BM is 2MX. Let's put them on the diagram. BM has 2MX in it. So BM, B to M, has 2MX in it. Let's put them on the diagram, what I said. So you can see the ratio. So this BM right here is 2MX. This is 1MX. It means that the line is in ratio. The whole thing is in ratio 2 to 1. It means that this piece is 2/3 of BX. And this piece is 1/3 of BX. Can I write up here? It means that BM, write it down here, Mr. Shaw. It means that BM this BM is 2 out of the 3 parts of BX, is 2/3 of BX. And then MX is 1/3. MX is 1/3 of the whole thing, of the whole BX. Right? And it's good to write them in terms of BX. Why? I already worked on BX. See here we have BX already. You know what BX is already. But remember, if you know a vector, like you know the road, this is the road B to X. And you can work a part of it, any part of it as you want. You can travel along that road, the whole road or a part of the road. Treat the vector like a road. All right? So we have these two that we can use if we need. 1/3 of BX, 2/3 of BX. That's what those are. What I want us to do now. So I must find BM. Let's look at the diagram and see over from B to M now. B to M. Oh, see here, B to M is this calculation. 2/3 of BX. So BM is 2/3 of BX. So BM is 2/3 of BX. And the BX is this up here that we just did, right? Let's write it down here. The BX, remember, is U minus 2V. Right? U minus 2V. So then the BX is 2/3 of this. So it becomes 2/3 of the part there, which is 2/3 U. 2/3 of this part becomes minus 4/3. Right? Put that on the calculation, so maybe it's a little bit clearer. It becomes 2/3 of BX, which is U minus 2V. So 2/3 of this, you get 2/3 of U, and then 2/3 this, multiply the 2 times the 2, multiply the 2 times the 2, you get 4. So you get minus 4/3V. That's what BM is right now. That's the answer. Then they say now use a vectors method to show that YA is 1 to 3. So we're using YM and YA is 1 to 3. So we need to find those vectors, YM and YA. Let's see if you have any of them yet. I can get them from the diagram. So we need YM and YA. All right, so the YA kind of easy. I have the portion vector of the Y and the A. So the YA kind of easy, right? It's OY minus OA. YA kind of easy. That's OA minus OY. O times the last minus O times the first. OA was what again? The OA was 2U, and the YO and OY was V. So it's 2U minus V. U minus V. 2U minus V. So this is 2U minus V. That's what the YA is. YA is that. We need to work out the YM now. Let's go get it from the diagram. The YM. Going from Y to M. So from Y to M, we can go Y to B out here and then go B to M. We have both of them. YB plus BM. That's what we're going to use. YB plus BM. So this is going to be equal to Y to B and then B to M. Y to B, B to M. So YM, Y to B is V. Remember, is V. See here. The Y to M is just this V. And the BM is what we just worked out a while ago. The BM is this. This is the BM. So we're going to be adding that. So we're going to put plus 2 over 3U minus 4 over 3V. Let's put a line between here. So separate the two vectors. They want to consolidate these two V values. So you can write this one, can write this V as 3 over 3, so it have the same denominator as this. So put this V as 3 over 3, so it have the same denominator. So then this then becomes that YM is therefore equal to 2/3 U, that's the only U term in there, 2/3 U, and then 3 minus 4 is -1, so you get minus 1/3 of V. So we now have these two vectors that we need to show that they are parallel, this one and this one. So that one is a multiple of the next. First, establish a relationship between them so that we can get this relationship. So we need to get the vector out, the fraction out of this one. So we're going to multiply it by 3, get the fraction out of it. Multiply this one by 3 to get rid of the fraction first. So multiply by 3, that get rid of these two fractions. So multiply this side by 3 first. We're going to get 3YM equals 2U minus V. And the 2U minus V is the same as this. It means then, by the two of them equal the same thing, we can equate this to this. Equate them. All right, so we can equate. I wanted that space, I'm going to do it down here. So let's do that part in purple. So now we're going to equate. Equate them, we're going to get 3YM is now equal to YA. All right, that's what we have. To get rid of the vector component, we take the modulus of both sides. So get the modulus of 3YM equals the modulus of YA. Now we're just talking about the length of the line. So you can drop out the arrows. So you're going to have 3YM without the arrows equals YA. You get a ratio, you're going to divide. You're going to divide this under here. And you can divide the 3 under here. So you divide. So you're going to get YM over YA equals 1 over 3. So divide the YA under here, divide the 3 under here. That's why you set up the ratio that they want, this ratio, YM to YA. So you have it. Therefore, YM to YA is 1 to 3. Is 1 to 3. That is your show. So show. That's the answer. You have shown it. End of this test. And that is that. Guys, have to go and practice these things, right? All right, this one, work it over again. Do it over. Work it over again. Get an exam paper. You want to get it right. That's not difficult. You want to do it over again. All right? You have to be able to do these things, guys. I set these questions all the time. All right, body good? Body
Yes.
okay? All right. All right. Gonna end it there for today. Tomorrow is what? Tuesday class and Wednesday. I think we're gonna do some geometry construction on Wednesday. I think that's the next thing that we're on, geometry construction. I think from next week, every class is the exam paper. Every class is exam paper. After that, exam prep, fully exam prep. I want to set some schedule to to do some marathon on some of the topics, some marathon class on some of the topics. All right, topic by topic, transformation, vectors, trigonometry, bearings, linear programming, coordinate geometry, you name it. All right, so 1 or 2 topics at a time, so we can get some nice revision going. All right, everybody. So that is the plan. That is the plan. I just give me that. Why am I getting that?